Nernst equation. This is one of the equation by which you can find out the potential of an electrode. I mean, you can find out the normal potential of the electrode. This equation is very important, and by using Nernst equation, you can find out the EMF of the cell. You can find out the potential of the electrode also. So in exam, you will get one question. Write the find out the EMF of the cell by using Nernst equation. First time we will do for an electrode. After that we will do it for the cell, because you know a cell contains two electrodes. So first time we will do how to determine the potential of an electrode. Actually, what is this equation? Nernst equation, it gives the relationship between the potential of an electrode and the concentration of the electrolytic solution. I mean, if you know the concentration of the electrolytic solution, then you can find out the potential of the electrode. So this equation gives the relationship between the electrode potential and the concentration of the electrolytic solution. Yesterday I have told you the electrode potential depends upon the concentration of the solution. If the concentration is going on changing, then the potential may be going on changing. So that is why how it depends on concentration. You can find out this by using Nernst equation. Now, what about the equation? Consider an electrode reaction. Consider an electrode reaction. Suppose the electrode reaction is this one, Mn plus n number of electron, n moles of electron, it gives M solid, Mn plus aqueous. Suppose this is your electrode reaction. That means I have considered general one. It is like this: copper 2 plus gain of 2 electron, it gives copper. This type of equation. Here M stands for any metal. So I have taken the general equation, Mn plus aqueous plus n electron, it gives M solid. If you want to write the Nernst equation for this equation, Nernst equation for this electrode reaction, E of Mn plus oblique M, I mean potential of this electrode, which is represent E of Mn plus oblique M, this is equal E naught of Mn plus oblique M. E naught of Mn plus oblique M means standard potential of the electrode. This is normal potential. This is standard potential. As I have told you, standard potential you will get in book. So that is the standard value, minus RT by NF ln. R means the gas constant R, whose value is 8.314. T means temperature. N means number of moles of electron. F means Faraday. As you know, Faraday value is 96500 coulomb. That Faraday value you have to use here. Ln means the natural log. Ln, concentration of the product divided by concentration of the reactant. It depends on your equation. What is your product? Metal solid. Concentration represented by square bracket sign. So concentration of metal solid divided by concentration of the metal ion, Mn plus aqueous. So like this way you can write the Nernst equation. The normal potential of this electrode is equal standard potential of the electrode minus RT by NF ln concentration of the product divided by concentration of the reactant for the reaction. Now, if you want to simplify this, E naught of Mn plus oblique M, I mean standard potential of the electrode, minus, as you know R value is constant, R value is 8.314. Suppose temperature is 298 Kelvin, 25 degrees Celsius, and it depends on the reaction. F is Faraday, 96500 coulomb, as you know the value. Ln means 2.303 log, you know it. Concentration of metal solid divided by concentration of Mn plus aqueous. Here Ln I have converted to log. Now one question arises here. Here I have considered temperature as 298 Kelvin, I mean 25 degrees Celsius. It will mention in your question, you have to find out the potential at 25 degrees Celsius. If the temperature is different, then the equation will be something different, value will be something different. Now after doing this, this is equal, you can write E naught of Mn plus oblique M minus this value, the R value 8.314, temperature we have considered 298 Kelvin, Faraday value 96500 coulomb, Ln means 2.303 log. When you multiply these values, then you will get 0.0591 divided by N. Here n depends on the reaction, how many moles of electron transfer, that n value you have to here, you have to put here log of concentration of metal solid. Solid substance concentration is always considered as 1 because solid substance concentration do not change. That's why you have to consider it as 1 by concentration of Mn plus aqueous. So this is the Nernst equation for this electrode reaction. E naught value you will get from your table, n value you will get from the reaction. If you know the concentration of metal ion, concentration of Mn plus ion, then you can find out the potential for the electrode. So you should know only about the concentration. This value you will get in your table. N value depends on the reaction. For example, this reaction here, number of moles of electron is 2, so n value you have to put 2 here. So if you know about the concentration, directly you can find out the normal potential for the electrode. So when you use Nernst equation, no need to put like this way RT by NF. Directly you can put standard potential minus 0.0591 divided by n log of this one if the temperature is given 25 degrees Celsius. Normally in question always the temperature is mentioned as 25 degrees Celsius. So if it is not mentioned, then you will get another value if the temperature is different, but normally temperature is always given as 25 degrees Celsius. So like this way, by using the Nernst equation, you can find out the potential of an electrode. And here you have seen this is potential, this is concentration of the solution. So Nernst equation gives the relationship between the potential of the electrode and the concentration of the electrolytic solution. So that's why I have given this equation gives the relationship between the potential of an electrode and the concentration of the electrolytic solution. So if you want to find out the potential, normal potential of an electrode, then by using this Nernst equation, you can find out that normal potential. Thank you.